Good day, and welcome to the Plant Engineering Webcast, Simplicity in the Cloud, the Benefits Behind Cycle-Based Preventive Maintenance, sponsored by Leading to Lean. I'm your moderator, Kevin Parker, and I'm happy to join you today on behalf of Plant Engineering. Here are some tips to help you get the most from today's webcast. If you experience issues with the slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. Control the volume of this webcast by adjusting the volume on your computer or on the webcast platform. For technical problems with audio or the slide presentation, click on the question mark at the top right-hand corner of the screen to access a list of system checks to try before contacting an online technician. If you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Type questions for our speaker in the Ask a Question box on the left side of the screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded. You will receive an email within a week with the link to the on-demand event. To download a certificate of completion, a PDF copy of the presentation, and additional resources, use the Event Resources tab on the left side of the screen. Those documents will also be available with the on-demand version of this webcast. I'd now like to introduce our speaker, Eric Whitley, Senior Account Manager at Leading to Lean. Eric Whitley has more than 30 years experience in and around manufacturing, including being Total Productive Maintenance Champion for Autoliv ASP, an automotive safety system supplier that specializes in airbags and restraint systems. Over the years, Eric has worked within industry sectors that include food and beverage, timber, construction, chemical, and automotive. He is an expert in lean practices and implementing lean execution software. Thanks for joining us today, Eric. The floor is yours.
Thanks, everybody. Welcome to the webinar today, and it's really great to be here. Thanks to Plant Engineering for having us this month, and really looking forward to kind of presenting this topic as we go forward and kind of introducing some great, really cool features that are being developed in the EAM world and in the CMMS world, and kind of going through that. But really, I want to dive into some very specifics about what some of that technology can do. And that's why I've kind of chosen cycle-based PMs as kind of our focus today, because I know that that is something that a lot of plants want to get into. I know it's something that a lot of people are interested in. And I really want to show you how simple it is and what it takes to kind of get to that cycle-based PM thought process. So thanks for being here. I really appreciate it. And so let's just jump right in here. I'm going to go to the first slide here is up. And so I want to talk a little bit about, kind of lay a little bit of foundation here about what we're calling a modern EAM. L2L is what we call a modern EAM. And what a modern EAM is in comparison to what we might see out on the shop floor as an EAM or a CMMS, and kind of go from there. And really the crux of the whole process and the crux of what makes a modern EAM system is the fact that, you know, there's been this revolution here lately in the last 10 years of the cloud, mobile devices, and then software design and the ability to design software in and around what we might call social intelligence. So we've taken that knowledge that we've gained through social media apps and, you know, different online apps like that where people socialize on a daily basis. We've taken that concept and put it into an EAM and into the CMMS realm. And all of those things have collided to make what we call the modern EAM. The other thing that a modern EAM really is this tool that now can incorporate, because of this technology, because of the cloud technology and design and mobile devices, this tool now incorporates all the aspects of a production facility. And what I mean by that is that your EAM and your scheduling and your production software, for the most part, really should be the same piece of software now. That technology is out there now. And so what that really gives us is the ability to capture all of the data that you need in order to kind of put forth the metrics that you need to put forth the right PMs and like what I'm going to show you here in cycle-based PMs. So it's really important to understand that there's been a revolution in CMMS technology. I've been teaching CMMS and EAM stuff for years and years and years. And it really has come to the point where we've all been wanting this type of software out there, and it's actually here now. So I do love this quote. You know, the maintenance work should be scheduled to optimize the balance between the minimal adverse impact on the operating schedule and effective utilization of maintenance resources. And I will tell you that I've taken that from this book. So I'm going to suggest that you actually use this maintenance planning and scheduling coordination as you look towards building your maintenance systems. I love that book and have used it for years and years and years as a basis of some of the stuff that I've taught. So anyway, so that's that. Let me move on to the next slide here and talk a little bit about some of the takeaways that we're going to get out of this presentation today. So the first thing I'm going to do is kind of try to lay some foundation of what I'm going to talk about here in the middle part and the end of the presentation. And part of that is to really understand what the three types of maintenance work are and to really have a good grasp of that is, and then where does cycle-based maintenance fall into three types of maintenance. And then I'm going to talk a little bit about the bridging of and how technology is kind of bridging that gap between production and maintenance. I mean, you know, maybe in your organization, I say this tongue in cheek, right? Maybe there is no animosity between production and maintenance, but I'm going to assume that for, you know, a good 90% of you, there can seem to be at some point in time a little bit of friction between those two groups. What technology has allowed us to do is to really kind of bring everybody into the same realm, into the same piece of software, which then puts everybody on the exact same level playing field. I'll talk a little bit about that as we move forward. And then I'm going to get into a few of the best practices when it comes to cycle-based maintenance and kind of understanding how to implement that and what you need to do to kind of start down that process, okay? And then, by the way, go ahead and ask any questions, chat those questions in there, and then we'll try to get those answered at the end of the thing as I go along. So, all right, so let's talk about the three types of maintenance work. That's really kind of where we need to start to kind of lay the foundation of what we're doing here. So, first of all, we all know the first one, and that is the emergency response, the reactive. And if you think about an emergency response, and if you think about that in the terms of, you know, like an emergency response system, you know, 911, what's your emergency? You know, 1 Adam 12, 1 Adam 12, see the lady on the corner of First and Main with the cat stuck in the tree. If you think about that moment, that emergency happens, and you think about that moment that information comes into the 911 call, we know exactly what time the cat got stuck in the tree. We know exactly where the cat is. We know who called it in. We know the location. We know who we sent out to get all of that. Your modern EAM system should capture all of that in the moment that it happened in real time. You know, we've all seen in the past the lines of maintenance guys standing in the maintenance shop in line with their paperwork in their hand and trying to recall all of that during the day. A good modern EAM system will capture that immediately, either through mobile devices or kiosk out on the shop floor. And so that's a very important part of this process, because we need to capture that data and understand where our reactive maintenance is coming from. The second part, or the second type of maintenance work, is that routine maintenance that we do, the PMs and all of that as we go through. And you should be able to manage that as well in your system. And then the third is that project and backlog. So the work orders. So there's a difference between that PM stuff and the projects. And so really today, for the cycle-based maintenance, what I really want to concentrate on is this number 2, this routine maintenance and service. This really is a major part of what we want to do, because we all know that reactive maintenance, for the most part, is an outcome or a symptom of poor routine maintenance. So if we can strengthen our routine maintenance process, we will then reduce the amount of reactive maintenance that we have. So when it comes to labor hours of our maintenance folks, what are they working on? Well, hey, we're so busy putting out fires, we have no time to do fire prevention. Well, really, the fire prevention is where you're going to reduce the amount of time that people are spending putting out fires. So same thing falls here. Routine maintenance is where we really need to spend our time in order to go try to reduce the amount of reactive time that we're actually doing out there. So let's concentrate a little bit on that as we move forward. So, okay. In routine maintenance, there are some options of how to do routine maintenance. The problem with these options is that instead of being able to pick one of these 3 to be able to say, we're going to do time-based, or we're going to do cycle-based, or we're going to do condition-based, you really have to almost mature into those processes. And what I mean by that, and what I've seen over the years, is that most organizations always will start off in the reactive world and then understand that they have to do some type of PM activity. And so they will move into the time-based world. And so they begin to do dailies, weeklies, monthlies, quarterlies, and annuals in their maintenance routine. And they understand that they have to do that, but they don't really ever evolve into that next level. And there's a reason why they don't do that, is because there's a thought process that we should evolve, but we're really not sure how come we can't get to that next level. And the reason is that because there's a barrier between time-based and cycle-based. And what I mean by that is there are some things that you have to have in place in order to actually mature to the cycle-based PM world. And then if you really want to mature into condition-based, you have to almost kind of perfect that cycle-based. And so we'll talk a little bit about that. But what happens is that a good cloud-based EAM or CMMS system, and I'm going to show you why this is true here in a second, will allow you to do that maturity. And the reason is because it begins to really break through those barriers that are keeping you from the cycle-based, and then at some point in time, the condition-based maintenance. There are barriers that you have in place, and we're going to talk about that here in a minute. Remember, let's go back to my initial statement that your EAM system or your CMMS system should be the same system as your production system. That's what a modern EAM is. So we begin to kind of develop some thought process around the fact that we've got this system now that can actually do some stuff for us in order to allow us to move to the cycle-based and condition-based. So what's needed? What do we need to do? And here are some of those barriers that I'm talking about. So the first thing that we have to be able to do in order to launch PMs on cycle-based is we have to have the ability to collect that cycle count. We have to have the ability to know what the cycles are on the pieces of equipment. And in the past, when people have tried to do that and organizations have tried to do that, what they usually do is that they usually have some type of process. Maybe it's even a PM itself, or maybe it's some type of reporting process where we're actually taking those cycle numbers either manually or off the PLCs for the piece of equipment. And then we're trying to do the math in our heads or on a spreadsheet or, in some cases on, old premise-based CMMSs to say, when should I actually then go do the PM? That has been a barrier in our way because that's difficult to do. That's very time consuming to do. And it's not very accurate to do. So the first thing that we have to do is we have to establish that we need a simple cycle count collection process in there, okay? The next thing that we have to do is, in order to get to that, your production and your EAM have to be able to talk to each other in order to understand that. Production side of the house, your MES or something like that, is usually where you're collecting your production numbers, or maybe it's not even there. Maybe it's still on paperwork. But then you have your EAM and your CMMS side where you're collecting your downtime and your PM, all that. Those two systems have to talk. And even one level above that, we would argue from an L2L standpoint, those two systems need to be the same system so that it's integrated in the software itself, that they are actually talking together and production and maintenance are working in the same piece of software so that it becomes easy. And I'm going to show you that here in a second. Then from there, we have to have the ability to auto launch those PMs. And what I mean by that is that, we talked a minute ago about doing the calculations and having to go grab those numbers and then come back and saying, am I within the scope? Am I within the time to actually launch the PM based on my cycles? That's a lot of work from a maintenance planner scheduler standpoint, or even a maintenance supervisor to do. And so it becomes very difficult. So what we need is a system that's going to auto launch when that cycle count reaches where it needs to be. Will it auto launch into the system so that it kicks out the PM based on that number? So that's another barrier that we've run into and something that we actually need for this to happen. The next thing that we have to have in order to break through that barrier that usually kept us from that is we need to have a simple way to do analysis. So if I set my PM cycles at 100,000 and I launch my PM and I continue to launch my PM at 100,000 cycles, and I realize that I'm not getting any failures, or maybe I'm getting failures at 80,000, we have to have a simple way to do that analysis. Right now, what we have is if you don't have the technology, you're having to do that all manually. And it just becomes so burdensome to try to determine what is the right cycle amount, what is the right, moment to launch that PM, how far in advance do I need to launch the PM in order to get it done before I reach that cycle count. All of that factors in to become just one of those things that doesn't allow us to get to that point, okay? And then the final thing here is that we've got to have a system that is going to simply allow us to edit the PMs on a regular basis. It should not be a Herculean task to go into a system and say, you know what, I've been launching this PM at X, I need to launch it at Y. That change should not be difficult to make. And unfortunately, in a lot of systems, it almost takes an act of Congress to go find the expert to do it, get it on the list, have them go in, make the change. And in some cases, you may even have to, call in outside contractors to do that. Yeah, that's old school, and that just needs to stop. And so the thing we need to have now is a very simple way to manage those PMs, to go in there and change that mode so that we can do that testing and do that A/B testing and make sure we're doing it right, okay? So those are the things that are needed there. So let me talk a little bit about, how do we get to this point and bridging that gap between production and maintenance, and how do we get to solving all of those problems that we have there, okay? The first thing that we have to do is we have to have a mindset. And I've always loved this statement, and I don't remember who in my career back in the day made this statement, but we need to understand that the production schedule and the maintenance schedule are the same schedule. If you have two separate schedules there, that those two worlds are working off of, then you've already set yourself up for failure when it comes to making sure that you're launching the PMs at the right time. So you need to make sure that you have the production schedule and the maintenance schedule are the same schedule. So let me show you how kind of the new cloud technology has allowed us to get to that point in what we're calling, the modern EAM system. So one of the things that we have understood that needs to happen is what we call the simultaneous tracking. And what do I mean by that? This is a look at L2L's what we call our operator portal. Basically, it is a design of our whiteboards out on the shop floor. We all know that, in production, for years, we've had whiteboards with hour-by-hour counts that tell us how much we need to do in order to hit that. And that's always been a really kind of cool little thing in order to try to help people understand where they are tracking their production. The problem with that is that is a totally separate system from the EAM and CMMS system. They're marking, in some cases, they're marking down like how much downtime they had or a note of what's going on there. But that's got nothing to do with where that data goes. The other problem with those whiteboards is that somebody has to come out to that whiteboard, take that information down, put it into a spreadsheet, take that spreadsheet back, put that into a different spreadsheet, and try to calculate some type of metric. We know that is highly difficult to do. Okay, so one of the new evolutions in software has been to take that entire concept and put it into a software, what we call the operator portal. And you'll see here that in this process, there are some things that we capture. The first thing that we can capture on this board is the production demand. So we're actually capturing this in the production demand, and we know exactly what and how much product we have to build. Why this is important is because we're beginning to set the standard for what are the metrics that we're going to use to measure how effective our maintenance system is, right? The other thing that we're capturing now is the production actuals. So through integration, we're actually capturing the production actuals and putting them right on the board. So nobody's having to write down a production amount here. They are getting those numbers directly from the PLC through integration there. The other thing that we're factoring in is scrap and rework. We're taking that right off the machines, and people can begin to see what the factors are, from a scrap and rework standpoint. The other thing that we're grabbing on this board is labor hours. And we're doing that, if you look down there in the bottom right, we're doing that because we're having people actually check into the operator portal, right? So now we know what the labor hours are in order to build this product. And then the final thing and the most important thing here on the operator portal is we're actually capturing that downtime. So now here is where on our CMMS side and our EAM side, people are putting in those downtimes. 911, what's the emergency? On the production side, we're capturing the cycles. All of that fits into then being able to calculate metrics in real time, being able to take and understand who's doing what on the production line. But the most important thing that it does is that now it's feeding information back over into the EAM side of the house, into the CMMS capabilities side of the house. So that area right there where it says production actuals then is actually calculating, and then it's feeding back over into this side of the house of the EAM. And what I mean by that is that it's updating the cycles automatically. So the cycle count on the machine is being updated as production runs. That data is being fed back over into the cycle count on the piece of equipment itself and updating there inside of the software. None of it's being done manually. None of it's being taken off of a spreadsheet. None of it's having to be collected off of a whiteboard. It's updating automatically right inside the EAM. Again, this is all the same piece of software. So it's just talking right directly back over and doing the cycle count on the asset itself. This is really, really important because when we do that, now what we can do is in the EAM portion of the software, we go in and we can set up a cycle-based PM. And we can set that cycle-based PM up to say at 100,000 cycles, I want you to auto launch this PM into the system so that then we can actually go perform the PM based on that. And you'll see here that on this screen that we're actually porting over those captured cycle base over into the system and updating this PM as to the actual count of the cycles. Then when it reaches that level, it actually launches those PMs into the system. So back to the beginning when I said that your EAM system and your production system must talk together, what we're talking about is all of that is in the exact same system as we go forward, okay? Then when that actually reaches that level of cycles, then we launch those out into the system digitally. So you can see here, here's an example of how at L2L, we actually will launch that cycle-based PM into the system, and then we can actually assign our resources, our mechanic or our electrician or our skilled trades, who's ever going to do that PM will then get notified that this PM has been launched into the system. The other thing that you get when you're looking at a modern EAM is that you're actually getting digital documentation that will now attach to that PM as it launches. So gone are the days of actually printing out PMs because you're getting that digital documentation as it goes into that, okay? So it's very important to understand that what's happening here is that the production side of the house is capturing production, the maintenance side of the house is capturing downtime, and those two things are meeting up in the middle in order to update the cycles on the cycle-based PMs and then auto-launching those cycle-based PMs out into the universe so that the mechanics can then go actually do those as those cycle-based PMs happen. Where this comes back into our earlier slide, now once we begin to understand where those cycles are and when our failures are happening because we're capturing those into the system, we can now begin to understand how to move from there to condition-based, because now that we have an understanding of when this thing is going to fail based on some type of cycles, now we can start watching the condition-based monitoring side of the house to say, is there a correlation between condition and cycles? And then we can move over into that condition-based maintenance. So it's a maturity process that we have to go through, but you've got to have the data and you've got to have those barriers removed in order to do that maturity, in order to go over into cycle-based and condition-based maintenance, okay? All right. So let's talk a little bit about best practices here. What are our best practices when it comes to cycle-based maintenance? The first thing is that we've got to understand how to establish our initial PM cycles. And what I mean by that is if we've never tracked cycles before in comparison to failures, even if we've plugged those into some type of mean time between failure analysis or some type of failure analysis, if we've never tracked the actual cycles, we've got to have some type of initial baseline to do that. So let me show you the kind of the process that I've used in the past to be able to kind of establish your initial cycle-based maintenance routine. The first thing is that we've got to understand there's basically 3 steps here. We've got to understand, like, what is your lowest unsolvable mean time between failure issue? And what I mean by unsolvable, you know, we all know that there are things on a piece of equipment that fail, and it's just obvious. Like, we should have caught that. So we can make the change there. So let's say if we have, you know, the wrong type of sensor, or if we don't have the right TPM program in place to clean the machine and we've had that failure, or if we just are making the wrong, you guys know what I'm talking about. So, but then there are those things that are failing that we are kind of scratching our head on. It's going to take a little more work. Those are what I'm talking about, is like, what is your unsolvable mean time between failure thing? So we want to understand how many days it is in between your lowest unsolvable, right? Then the next thing, once we have that, and I'll show you the calculation in a second. Once we have that, then we want to understand how many times this has happened in the last 365 days. So we want to divide that into a yearly production total, right? And then we want to multiply those average days by that lowest unsolvable mean time between failures. So let me show you here. So as an example, let's say you have a proc sensor that's failing roughly every 36 days. We're not really sure why it's failing, or maybe it's going to take some type of engineering redesign to do that. It's not something simple to solve right now. So we're going to call that our lowest mean time between failure, right? And as an example, our annual production off of this piece of equipment is 25,000 cycles. Now, I'm going to talk about this here in a minute. So remember, we're talking cycles. We're not necessarily talking parts. We're talking cycles. And that's a big thing to remember as we go through here. So what we're going to do is we're going to divide that into that. And we come up with, in this case, we come up with about 68.5 cycles, right? So now what we're going to do is we're going to take those 68.5 cycles, we're going to times them by those 36 days that we have, and we see that we're right at about 2,466 cycles. We're going to round down. Now, in this case, because we're only, 16 parts away from that cycles, it may not be that big a deal. But listen, if you make 1 million parts off of this piece of machinery, it's a big deal if you are 2 or 3% off. So you're going to want to round down in order to that. Again, one of the things that we're going to come up with is an easy way to change that. And the new, the new CMMS and the new technology allows us to do that. So it's going to be very simple if we realize we're wrong, just to go in and change it. So you're going to want to round down. So this is how you're going to establish what your first set of cycle counts are going to be as you go forward, okay? Now, back to the cycle thought process. We have to remember that we're talking cycles on a piece of machinery. So strokes on a press, turns on a turntable, anything like that. In some cases, a piece of equipment may stroke 2 or 3 times in order to make a single part. This is why you don't want to count parts. You want to count cycles. What our software has allowed us to do is to have what we call a cycle count multiplier. So in the software, you can actually factor in this cycle count multiplier. Hey, it takes 3 cycles of this machine to build 1 piece of product. So we want to factor that in by 3. So every time the thing cycles, it counts it correctly inside of the system. And then we can set our PMs to that. And that also does that on the opposite. Sometimes we can stamp a part and or run a press as an example and stamp, and it'll make 5 parts. So we want to, in production, we want to say for every 5 parts that we produce out in the production side of the world, we want to count 1 cycle over here on this piece of equipment. So make sure that if you're looking at a new CMMS system that kind of does have that cycle-based system, that it has this little feature, because it's a big deal. We call it a cycle count multiplier. So make sure that it has that in there, and that you can actually count that. So that's another big feature that you need when it comes to that cycle-based stuff. The other thing that it had that you're going to want to look at is this feature called movable tooling. And why is this important? In a system, and in a production and manufacturing environment, you have tooling that you move around the plant. You may have multiple pieces of tooling that can be interchangeable on multiple pieces of equipment. And you want to be able to understand when you want to go PM that tooling. If you use the same thought process of capturing cycles over in the production side of the world and putting them on an asset, you then simply can make the step that says, if I'm going to capture cycles on an asset, I then also want to capture the cycles on this piece of tooling. What you have to have, though, is you have to have a system that knows when and where this tooling is at any point in time. If I take a piece of tooling off of machine A and I move it to machine B, I want to be able to count the cycles that that tooling performed on machine A, and I also want to be able to count the cycles that that piece of tooling performed on machine B. So what I need is a feature then inside of the system that allows me to move that tooling from one machine to the next, and then understand that all of the cycles that get produced on that single piece of tooling should be then put towards that tooling as it's on that piece of equipment. So we call that movable tooling within the system. So what happens is that when your changeover crew or your operators or whoever you have doing the changeover, when they change that piece of tooling, they simply go in the system and move that piece of tooling from one machine to the next. Then you can go set up PMs for that single piece of tooling to launch on cycles. And those cycles get updated whenever that piece of tooling is on a piece of equipment. So what you can do in a system here is that if you have tooling, 10, and it gets taken off and put on a shelf, and then a month later, it gets pulled off the shelf and put on machine B, the cycles then begin to start again on that, and then it will launch that PM right into the system. So this little tool of movable tooling is really an important thing to have, because you want to be able to do your PMs on that stuff. So really great little feature to look for as you kind of, move into the new realm of the modern day EAM. Okay, so let me do some conclusion points here. Conclusion, your EAM and your CMMS should be linked to your production system, or in our case, it should be the same system, right? What we call the modern day EAM. That is the very definition of the modern day EAM, that no longer should your production data and your downtime and your CMMS data be separated. It's all the same data set, and you need to be able to use that, okay? You need to understand that there are technological breakthroughs that have been made in cloud-based CMMSs, cloud-based EAMs, that break the barriers of those time-based and allow us to move into the higher level of PMs, which is the cycle-based PMs, okay? your CMMS should be auto launching these PMs based on cycles. You should have that capability. If you don't have that capability, it becomes very difficult to try to move into the cycle-based PM realm. Okay. The modern day EAM really is the tool to bridge the gap between production and maintenance. And because I will tell you that because everybody is playing off of the same data set, there's a lot of stuff that goes away with that. We have a saying here at L2L that if it's not in L2L, it didn't happen. So when we meet in the morning meeting and we say, I had this much downtime yesterday, and this group says, no, you didn't. And there's no ambiguity because we're all in the same system, and there it is right there in the system that we can pull up and look at. And then we just make the statement, if it's not an L2L, it didn't happen. So really, there's a lot of benefits of having everybody playing in the same piece of software, okay? Remember, always establish your cycles based on your lowest mean time between failure issue and how many cycles is in there. And those that calculation is in these slides that you'll be able to use. And then the other thing is that this movable tooling feature has really revolutionized our ability to do the PMs on those pieces of tools, those dies, those presses, all of those things where we move that tooling around as we go through. So anyway, so there's a little bit of conclusion to my presentation, and thanks for having me today. And so I'll go ahead and take any questions as we go forward. So anyways, I'll turn it back over to you guys.
Well, thanks so much, Eric. That was really an interesting presentation and a unique take, I think, to a great degree on where the maintenance function is going. So thanks so much for that. For our listeners, type your question in the Ask a Question box on the console and click send. We will get to as many questions as we have time for. Questions that are for today's presenters will be answered verbally. Please take a moment. Well, let's not get ahead of ourselves. Let me ask a question first. It seems much more practical and realistic to base condition monitoring on cycle counts than it does using sensors to assess actual performance of the machines itself, where you might call that predictive or something like that. Yeah. How would you compare the two approaches?
Well, what I like, the way I like to see it is that it's an evolution, right? If we go out and just, let's say we start off with condition-based monitoring as our mantra, this is where we're going to go. The one thing that we don't understand with inside of that is that we have to sit around and still do the work to say, okay, I see this data on my condition, and then I can compare it to my failure. What going from cycle-based to condition-based monitoring allows us to do is that we can then begin to see and begin to correlate that data that, hey, I know that I have a mean time between failure that I've done the calculation in that has cycles. I know that I should be coming up on a failure. So now I'm going to begin to watch my condition and see if I see a change in that condition. If I don't see a change in the condition that correlates with my cycle time or my cycle count, then I know I can either make some adjustments to my cycles as far as failure goes, or make some adjustments to my condition monitoring processes, because I saw a failure and my condition monitoring didn't tell me that was coming. So what having the cycle count allows us to do is see when I know those failures should be happening, and then be able to correlate those two things together. So
good.
Hopefully that answers your question.
Another quick question, and that's about rotating equipment. I would think that this is especially good for a lot of different kinds of rotating equipment, which is such a big maintenance item, if you will.
Yeah, absolutely. Because and when we rotate equipment, what we want to be able to do is have a way to capture that as we move it, right? So it really is kind of the next step in being able to see when those failures are going to happen, even though we may be taking cycle counts in one spot versus another spot there. So yeah, it really is a game changer.
Good. Now to switch to another line of questioning, are there any disadvantages to switching to cycle-based preventive maintenance?
Well, I think, sorry here, I think the only disadvantage that I would see going to cycle-based is if you're not able to capture those cycles in a meaningful way. So if you are relying on, we all know that there's some failure factor in having people take data and asking people on the shop floor to take data and write it down on a piece of paper. We all know there's some margin of error in there. And so if you're asking people to write down those cycles and then inputting them into your CMMS, you are, you're factoring in the fact that you may have some error there. With the system like L2L, you're taking away all of that error in there. So other than that, I don't really see any disadvantages because it's all advantage. We all know that, it's much easier to understand when to change the oil in your car based on mileage, as opposed to trying to remember how much I drove in a time frame. So yeah, no, I only see it as an evolution on our way to that higher level of PMs.
Good. And one of our listeners is asking, I think, what are the most common mistakes you see when teams switch to this method, or what tend to be the biggest challenges?
Yeah, I think I kind of the biggest challenge is always just getting the right data and collecting the right data. So some of the biggest mistakes that people will do as well is to overestimate the amount of cycles that are in between failures. And then the other thing that I would say another big mistake that just kind of popped in my head is people's inability or lack of systems, processes, or protocols to go make adjustments to the cycles when the failure happens. So if a failure happens on third shift, and somebody goes out and changes something out and that doesn't get documented, listen, that's a failure that needs to be factored into the cycle count. And we need to understand that, hey, we're doing a PM every 25,000, but we had a failure at 18,000 and nobody documented that. And so we are way over on our cycle count. So we need to be able to make those adjustments as well. So that's the other thing, is just not being able to capture and make adjustments to the actual cycles. So
good. In the past, I've certainly heard about EAM systems that had their own procurement functions within it, but not as much about the idea of combining an MES and an EAM. Is that in fact where the leading to lean solution is headed?
Yeah, absolutely. I mean, that is really what sets us apart is the fact that we understand that the maintenance function is not a standalone function in and of itself, that it is an integral part of running a facility. And if it is an integral part of running a facility, then all of the data that's being generated over on that production side needs to be a major part of the maintenance process. And so what we've done is we've designed a software that actually integrates all of that together so that we're seeing a single set of data source, making decisions, not making maintenance decisions and production decisions. We're making total facility decisions based on all the data that's sitting right in front of us.
And that feeds in back to the production system in terms of changes to schedules and things like that as well.
Yeah, because L2L has an entire production side where you can do production scheduling, e-Kanban, your Kanban cards, your product orders, all of that then filters over so that maintenance and that whole production side is talking. So everybody understands. Again, the maintenance schedule and the production schedule are the same schedule.
Cool. Now, you talk quite a bit about cycles, obviously, in your presentation, but perhaps it bears just a little bit more, because one of our listeners is asking, how do you really determine what a cycle is for a machine or a piece of equipment? It's not equal to a part. So, how do you make that bare determination of what a cycle is?
Yeah, well, we actually have a little bit of, and I didn't really go into it in depth, but we actually have some functionality built into the software that we call a cycle count multiplier. So you can look at a machine and then you just kind of enter that factor into that piece of equipment and says, for every single stroke off of this machine, I produce 5 parts, or for every 5 strokes, I produce a single part. And so there's just a little field that you go in there and you put in that factor, and it does the multiplication for you, and then puts the correct cycle count inside of that asset. So
good. Yeah. Are there any industries where this approach is particularly beneficial, or where leading to lean is seeing particular pickup?
Yeah, I mean, obviously through the discrete manufacturing industries, right, where you're building a bunch of pieces, parts all day long, and you're counting those pieces, parts all day long. But it also works as well in like the process industries, oil and gas, and in fleet management as well. You can actually put mileage as the cycles or hours as the cycles into the system. So we equate mileage and hours as the same as a cycle. And so you're managing your assets through that. So yeah, there really isn't any type of industry where it doesn't work. Where it really doesn't apply is to large assembly type, tabletop assembly type manufacturing. If we're building, computers on assembling computers on desk or something like that. So, but other than that, there isn't a lot of facilities where it doesn't apply, because we can track all that throughput in the system.
Good. Now here's a question from someone. I can see by their company that they're in the midstream oil and gas industry, and they're saying on a reciprocating engine such as a compressor, we typically look at runtime hours. Should we be looking at RPMs for the cycle count, as these units can vary from several hundred to a few thousand RPMs?
Yeah, no, I'm with compressors and stuff like that. I've always just looked at the hours. Like I think I just said that here a second ago, where we can equate those in the system to capture hours in there. That's an interesting question about the RPMs, though. If you have something that's running at high but then again, I would still then just go right back over and say, the hours between PMs is a function of how hard the thing's running based on its RPMs, and so I would still probably go back to hours. So, and we can capture those things.
Yeah, I'm sorry if this is getting repetitious, but these are actual questions coming in from our listeners.
No, that's totally fine.
Yeah, and they're asking, how do you factor operational inefficiency? For example, pressure settings in a separator causing lower output.
Yeah, so operations inefficiencies, what we do is that we actually will see it over in, so our software has the ability to put cycle times for that piece of equipment. So if you're seeing some degradation in the cycle time of a piece of equipment, you're going to see it in the performance of the machine. Back to that, I don't know if you remember that screen that I showed. You have your demand versus actual, and so then you're going to start to begin to see that. We also have protocols in the software that allow an operator, if they are seeing lower throughput based on lower cycle times, they can notify the maintenance, not necessarily as in a downtime, but hey, I'm having a performance problem, I need somebody to come out. They launch a dispatch in the system, and that dispatch then brings out the right resources to come take a look at it. The other thing is that if you are actually monitoring those pressures, then you can set up through integration in L2L that if that pressure goes below a certain point, it will then launch a dispatch into the system that also does the same thing that we want the operator to do. So we have open APIs on the backside through integration that's collecting all of that condition-based monitoring information, pressures, sensors, heat, vibration, all that stuff. And then when they reach a threshold, it'll actually auto launch an event into the system that says, hey, you've got a problem.
Good. Now, someone's trying to get a little bit tricky on us here, and they're asking if there's a product variance within that cycle which causes shorter or longer wear. Is there something you can do in the software? And they're using the example running stainless steel parts as compared to some softer steel.
From a cycle count, it really doesn't know the difference, but I will tell you that from a product variation standpoint, we do have products. Those products will be in L2L so that when you actually change over from product A to product B, product A has its own data set of cycle time, stuff like that. And then product B will have its own, so that when you change over in the system, L2L knows that, and it will recalculate the metrics based on, product A versus product B. So then you could go back and look and say, how many cycles did I run when we were on product B versus how many cycles did I run when we were on product A, and then make some correlation there. So yeah, you could pull that data from there.
Good. There's someone asking here, is there any type of equipment that at the end of the day, it's probably more practical and better just to go with reactive maintenance as opposed to preventative?
Yeah, obviously in the maintenance realm, we do have some run to failure stuff. That was more prevalent a long time ago where we had run to failure stuff, but the technology today and the cost of, a failure can be, pretty high, 4 to 10 times more than actually doing something on preventative maintenance. So we just have to factor in that cost. Are we willing to take that gut punch of that 4 to 10 times more cost, 4 to 10 times more time wise, and just let something run to failure? So, but yeah, there are still factors out there in the industry that where you say, this thing is just better off run to failure. So.
Good. Another question. What do you think talk about the implementation of cycle-based preventive maintenance? Any estimates on how much, it can vary widely, I would imagine, but any thoughts on how long that would take and how much resources are needed? That's a pretty broad question. From my standpoint, obviously we think that implementing cycle-based maintenance is really an easier thing if you have the right piece of software in your hands. It takes our software. You can install our EAM, our modern EAM system, within 4 to 6 weeks from the time that you say, let's do it. 4 to 6 weeks later, you're actually taking data to begin to understand that. So it's, but if you are transferring over from time-based to cycle-based maintenance, I've always seen in the system, in the industry, is that you always use your Pareto data, concentrate on your largest failure factor, and then go concentrate on that. Use a very pragmatic approach to going and doing it. Look at what's causing you the most heartache and go start on that, and just keep hitting that number one tall pole on your Pareto chart. And eventually you're going to get there. So it just depends on how fast your organization is willing to move the needle on that. So. Good. Well, we're down to pretty much our final minute of the webcast. And here's a topic that you've certainly addressed as part of your presentation, but it gives you a good chance to do a brief summation. And the question is, what's the difference between a traditional EAM and a modern EAM?
Yeah, a traditional EAM is usually an on-premise software. It's usually only used by the maintenance department. It only factors in those things that maintenance deals with. work orders and PMs. It's printing out PMs. If you have a maintenance organization that picks up PMs in paperwork, you have an old CMMS system. A modern EAM system is taking all of that production data. It's actually part of the production. The production department uses it as their basis to deal with their production, and the maintenance organization is putting their information, and all of that data is being met together in order to calculate your metrics, to launch your PMs, to schedule your production, to track your tooling, to all of that stuff. So the very crux of a modern EAM system is that it's probably cloud-based. Everybody can use it on a mobile device, and people can access it anywhere they want, wherever they have a web browser. So that's a pretty good indication of a modern EAM system.
All right, great. Thanks so much, Eric, for sharing your time and expertise with our audience. I'd like to thank the audience for the great questions. I'd also like to extend special thanks to our sponsor, Leading to Lean, for sponsoring today's event. Now that we're just about done, we'd like to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it, because we use this information to improve our webcasts. Finally, on behalf of Plant Engineering and Leading to Lean, I'd like to thank you all for attending.
Thanks, everyone.